In this problem right here, we're seeing a few different units, so I'm going to go ahead and write them down. So I see 155.7 joules as note, that's a Q. I'm seeing a 14.4 grams, so that's a mass. I'm seeing a temperature change, so delta T, and remember it's already T final minus T initial. So I'm going to do cooled 2, so this is the final was that it was 27.1, and that was the temperature change right there. Determine the specific heat capacity. So that's what you're looking for. So we know the formula is Q equals M times C times delta T. If we're solving for C right here, then what we want is we want to divide and get rid of anything around the C. So we want to divide both sides by M. So those will go away. And then we want to divide both sides by delta T. So those will go away. So essentially what I have now is C is equal to Q over M times delta T. And I'm going to put it in as 155.7 joules over 14.4 grams times 27.1 minus 111.7. And note that it is heat being released. I wrote this as though it was heat being absorbed, but when it's released, it needs to be negative. Another way you can know this is that the C value should always be positive. Note that the answer that I should be getting is this answer right here. So let's try it out. Minus 155.7 divided by 14.4. And then again, if you are using multiplying sign on the bottom, make sure that you put a parentheses around it. I'm using the divided sign again, but I still have to have a parentheses around that operation. 0.7. So that gives me 0. And that's 1, 2, and then notice it says 7, 8, so the 8 bumps that one up. So that's 0.128.